Woohoo!
So today we're going to talk about one of the biggest topics in philosophy. Interesting, right?
Mm-hmm.
That topic is time.
Time.
Yeah, it's something that we don't think a lot about as human beings on some level, but that we experience every day. And we're going to talk about it mostly from a phenomenological perspective. That is how it feels as a human. But before we do that, I think that we should just spend a brief moment talking about what physics and science have to say about time. So let me ask you this. In physics, is time real?
Yes. I think so. I think the scientific thing of time is just things changing. If space doesn't exist, then time also doesn't exist because time is just sort of the measure of space, and the things within it are moving and changing over time.
I think that most physicists would say that time doesn't exist without objects.
Yeah.
And that it is objects changing that gives us the sense of what time is.
Mm-hmm.
And if there were no objects, there would be no time.
Yeah.
But on another sense, physicists don't see time exactly as we talk about time from a phenomenological perspective. I think that most physicists these days would describe the movement of time as a phenomenological illusion. And I don't want to get too much into physics because it's a little bit off topic for us, and it's a complicated subject.
Yeah.
But Einstein's general relativity essentially established something that we call space-time. You've probably heard that before.
Yeah.
And I only want to touch on that because I think that people make that into something mysterious. Like time in physics is the fourth dimension. And, the new dimension, that sounds super, exciting and weird.
Well, it's just the measure of stuff in this dimension, right?
Well, yeah, so all it is it's a new vector outside of 3D space.
Yeah.
Right? So one way to understand that, because it's hard to visualize four dimensions.
Because we live in 3D.
Because we live in 3D. But we really live in 4D. And how you can visualize that is this. Imagine a graph on a computer, right? And obviously you could show the 3 dimensions of where a dot might be. Mm-hmm. Now just imagine that you have a slider underneath that graph.
Gotcha.
And you can move it forwards and backwards.
Okay.
And that dot moves as you advance it forward or backwards, right? And that's just the dimension of time.
Oh, cool.
Right? So it's not mysterious or complicated or weird or mystical or anything else. By having another dimension in physics, it just means it's just another measurement that you have to take in order to determine where something is.
Yeah.
The one thing that is a little weird, though, about physics is they describe that space-time as a block. It's described as the block universe. So in that sense, everything, all things, all possible time states are simultaneously there.
Okay.
Physicists would say the experience of reality is like watching a movie.
Yeah.
The way physicists see that reality is like looking at a DVD.
That makes sense.
So if you look at a DVD, right, and I know it's a little bit archaic at this point, there's not a lot of DVDs around.
No, I understand what you mean.
But if you look at a DVD, like that whole movie from beginning to end is just right there. And then you could slide that little toggle back and forth and, you could...
So, time and space is all there, but as people, we are moving through space, we're moving through space using time. So, we can't really, perceive all instances. When you say everything exists simultaneously, it's difficult to describe it because obviously simultaneously sort of means things that are existing at the same time. But what you're describing is that all time sort of just existing on the same plane of existence.
Exactly. And actually, my use of the word simultaneous was not good.
Well, yeah,
because it's confusing.
But the reason that you used it is because it's just difficult to explain in our terms because we experience time. Like we like second after the second, like
That's
we
right.
can't go back.
It's hard when you're in the movie to step outside of the movie and see the DVD.
Yeah, exactly. Because you're not able to like go out and perceive the DVD because you're living in the screen.
Just one more small note on general relativity and how it describes time and why it needs to be incorporated with space into essentially a fundamental dimension of the universe, is that time can change based on how much gravity is present.
Yeah, that's what always confused me.
Yeah, and the math actually shows that, and real physical experiments show that. We've actually proven that. We've actually taken clocks and we've flown them up high above the Earth's atmosphere and put them on the ground. And the clocks on the ground that are closer to gravity, have a stronger gravitational pull, move more slowly.
Yeah.
They lose seconds compared to the clocks that are flown higher.
It's always hard for me to like think of like whenever people bring up like things like, oh, like there's like this one thing where it's like, okay, there's like there's just like two people that are twins and one's like an astronaut, but like who's older at the end of like a certain amount of time. And it's like it's always confused me how like time can be sort of like malleable and changeable like that, because obviously here it seems like time is just like constant, like time is an unchangeable, like it's like sort of like a four-dimensional, like sort of like uncontrollable, like it feels something outer, like something that's you can't really even
that would never change. It's static.
That would never change. It's static. But it's like when you think of time in like a different way, where it's like it's just another way of measurement, another way of like measuring how things change, then you sort of understand how time can change that way. But still, I can't really wrap my head around it. I'm just more inclined to thinking, oh, well, maybe like the clock can't, like maybe the clock was moving slower, but time itself is not moving slower. But really, the time itself is moving slower or faster, depending on where you are. It's just like I can't really think of it.
When people try to understand time dilation, which is the ability for time to speed up or slow down based on gravity. Once again, it's something that seems mysterious, but it's not once you break it down. Once you understand that in physics, time is literally movement by objects. Clocks.
Yeah.
Right? That is time. It is literally something moving, right? So you can imagine that as you get into a denser gravitational field, it's almost like molasses. It's like it's harder for things to move. Things move almost more.
Yeah.
Do you know what I'm saying? It's thick.
Yeah.
And the thing is, it's not just like the movements that we can see. It actually goes down to the subatomic level. So literally, atoms or electrons or electron decay or whatever the smallest measurement you could make.
Yeah, and so if you were like if you were in a place where like time was moving slower compared to on Earth, you wouldn't perceive it as moving slower because you yourself are moving slower. Like your brain is perceiving things slower than how it was before.
Exactly. The chemical signals and the electronic signals in your brain would actually be just as slow as everything else.
Yeah.
So it'd feel exactly normal to you, but from an outside observer, you'd be moving very slowly and, look like you weren't moving at all, really.
Yeah. Explaining it like that like makes it easier to understand, but it's just like when you think of like when you're so used to thinking of time as this like static thing that's like completely like that's like difficult to understand otherwise, it's like reducing it down just to things moving, which is like how it actually is. It's like hard to like make that perspective shift.
For sure. And the reason why I wanted to start with the physics and kind of demystify it a little bit is, in general, I find philosophers, when they talk about things that physics has understood for us, to be absolutely terrible. They love trying to like make it all mysterious and like, quantum physics is the seed of consciousness and all sorts of just literally meaningless statements. But once you break down the physics, it's not particularly complicated.
Well, I think philosophy in general is tending to make tending to like, even though it's like going after the answers, it can sometimes make things seem more mysterious than they actually are.
I think bad philosophy can do that. I think that in, good philosophy, I think breaks things down. And of course, it's all just human thinking. Okay, well, so now that we have a basic understanding of how physics views time, let's step it back into our dimension, right? The human dimension. And that is time consciousness. Probably one of the better thinkers in describing this was Martin Heidegger in his book Being in Time. And to separate the way that we feel time from the way that physics describes time, he invented a word essentially which we translate as temporality. So let's talk about temporality. That is how time feels to us. Now in physics we describe the block time. Does that correspond with how we experience time?
No. Well, it's like you described before, like the DVD versus movie. In physics, you're sort of looking at like the biggest possible picture, like you're looking at like the entire universe. But dimensions aren't just like that. Like we can look at them like that. We can comprehend them almost like that, but we can't perceive them as a block because we are inside of that dimension. We are living inside of that dimension. And so, although physics can see time all as one thing together, we are moving through the progression of time, and because we are objects moving, we are objects perceiving time, like our brains are firing, like we are subject to time in that, like even in that, like if time moves faster, we move faster, if time moves slower, we move slower. So it's different from how, like even a physicist that understands block time will still be moving through time because that's just how it is. Because 1 second after the next, we can count 1 second after the next. We can see things moving because this is just the speed at which we are moving. Physics is, when you're looking at block time, you are not moving through it. Like everything, like nothing, when you're looking at block time, when you're looking at all time as one, things aren't moving because you're looking at them all in one space.
For sure. So for us, we experience time as flowing. Talk to me about in the experience, is that flow unidirectional or does it move both ways?
It just moves in one way.
And what way is that?
Forward into the future. When you think about it, like time is sort of like this other thing, like this static being, which is like difficult to comprehend, then it's like time travel seems like all the more like mysterious and sort of like possible in like a scientific way. Like, oh, if we were like able to finally comprehend how time actually is and how it works, then we can like spin it back or move it forward, or like we can like travel throughout it. But then when you actually get down to it, it's just like objects moving. It's like, okay, well, we're moving forward. And it feels like if you were able to control time, then like that wouldn't work because then you would be moving backwards with the time. So like not only would you be like moving in age backwards, but then like, well, like you could like totally explain to me if I'm wrong. But like just like the way I'm comprehending it now is that like if you were to control time and like do time travel and to move backwards, then you would be like moving backwards faster somehow, and you'd be like shifting to that past time, but then you would be as you were in that past time, which would be like younger, but then also because your brain is moving into the past as well, you would not have comprehended that you've changed time at all. You just think like this is where you are.
It would just be like reversing the DVD a little bit.
You would not remember the future.
Stephen Hawking essentially said that going back in time is impossible because it would essentially break physics.
Yeah.
Let's talk about one of the philosophical consequences of physicists' view of time and block time. If the DVD is already there, and that's really what reality is, then that sort of seems to throw a little bit of water on our existentialist philosophy, where our choices matter. In physics, is there choice, or is it all just already written?
In terms of physics, I think it makes sense that like certain things, like I don't know, like the heat death of the universe or whatever, have been are like uncontrollable, and like that's how it works. But I think when it gets to the smaller point when it just gets to the smaller point in the universe, like where we are right now, even if you look at people like, okay, it's all prophesized before because of like evolution and biology and like how like we're controlled by our environments and our psychology, and like so like are we even us really because this is how it works? Yeah, we are, because sometimes you can see like the existentialist moment, you can see two paths before you and know that you can be equally likely to choose one over the other, and it's impossible to decide which. And that means that there is, like if you believe in like multiverses or whatever, then there is another universe in which you chose that other path. And that means that not everything can be predictable and can be exactly controlled. And like, I don't know, like maybe there's a physicist claim where like actually it is controlled and like you were always going to choose that path. But I just think that's kind of stupid and doesn't make sense. And I also think that if we're thinking about it through human consciousness and how the human perceives time and how we perceive time, then I think it's pointless to question how much of us we really are and how much of us is predetermined and controlled, because we are here right now making these choices. And even if those choices were somehow made before us, for us, and even if we somehow cannot be perceived as how we are, even if I am the result of so much biology and psychology and sociology coming together to form one person, and that person would always exist and would always make the same choices, I am still me as I am, no matter how I came to be here. And that means that I can choose to do things and have free will. And so the idea that free will is not free because you were led into this way by a million different factors is stupid, because the person I am right now has the ability to make those choices, to have freedom to make those choices. And even if the person I am was predetermined in some way, I am still that person, and that person still has the ability to make free choices.
Well, I think that you described that very well. I think that succinctly what you're saying is it doesn't matter how we came to be. Mm-hmm. As we're going through this movie, we are who we are, and it's us who are making the decisions. And whether there's some sense that was from the beginning of time or not, it's irrelevant. We're still us right now going through the movie, and we're still making decisions.
I think arguing about who you are as a person and like if you're really like in control of yourself is sort of the same as arguing about whether or not we're in like a computer simulation, or like whether or not you're the only person that exists and like your imagination is forming the world around you, in that it has zero relevance on who we are right now and how our choices are made.
I tend to agree with you. Well, and so let me just be explicit about this. One of the issues with the block universe is it's not a very satisfying explanation.
Yeah.
It doesn't correspond with human experience. And the reason why physicists are willing to have a theory that totally doesn't correspond with human experience is that time and again, we found out that our human experience is so limited. When you get to the extremes of super big things or super small things, that it just, our perceptions weren't right. And so that's why physicists are justified, I think, in being skeptical of time as we experience it being real. But have no doubt that physicists don't agree about this universally. And I think most physicists would agree that there's something inherently and deeply unsatisfying about the block universe. And just to give a little hint as to the line of reasoning that this recent physics is exploring, it involves information theory. And what we know about information is that it's physical, right? Like it has physical constraints, right? Like it needs real things to happen. Mm-hmm. And the question that he has begun to ask is, at that point of the Big Bang, when there was essentially that compressed state of space-time, there doesn't seem to be enough space or matter or stuff to contain all the information to the end of time. So from a physics standpoint, there's a problem there.
That makes sense. We hope that you enjoyed that video, and if you did, please consider checking out the next one in the series.
Or some of our other series on philosophy and life.
We upload videos every Friday, so don't forget to like and subscribe.
Like and subscribe. See you next week.